So how could we figure out what this whole angle is? The angle that I have here. What could I do to figure that out? Any ideas? Demetria? Remember when you first started with trig and you had to find the angle? What is it that you did in your calculator to find the angle? Yeah, tan -1 or sine -1 or cos -1, okay? So I want people on this side of the room to do inverse sine of -4 over root 17. So sine -1 of -4 over root 17. Figure out what that is. People in the middle, I want you guys to do inverse cos of -1 over root 17. And then these two tables, I want you guys to do inverse tan of 4. Okay? So what do you get over there? Alyssa and Aaron, what do you guys get for inverse sine of -4 over root 17? So let's just say negative 76 degrees. Okay? And what about inverse cos? Anybody in the middle get that one? Positive 104? And then what about the inverse tan of 4? What do we get for that one? 76 degrees. Okay? Now, all three of these angles are different. And also, this is fourth quadrant. This is second quadrant. This is first quadrant. And we want an angle in the fourth quadrant. I mean, in the third quadrant. So these all are going to get me there, though. What do all three of these angles have in common? Pardon me? The reference angle. All three of them have a reference angle, and the reference angle is 76 degrees. So guess what? That's what we want here. That's the reference angle here. So the angle that we're trying to find is 180 plus 76 degrees. Okay? So when you take the inverse sine or cosine or tan of any of these, you're going to find the reference angle. Okay? And it may not be the straight up reference angle. It may be the negative reference angle, or in this case, it's in second quadrant. We have to search around a little bit for the reference angle, but it's going to give us the reference angle. So if it were me, what I would do is, first of all, I wouldn't worry about putting the negatives in. I would just do inverse sine of the positive or inverse cos of the positive, because you know you're going to get the reference angle anyways, and that way it'll give you the first quadrant reference angle. Or if I were going to do it, I would do this inverse tan, just because, look, it's easier to put in 4 than it is to put in 1 over root 17 or 4 over root 17. So I would just pick the one that's the easiest to find the reference angle, and then from there you can find the actual angle. Okay? Now the second part of that is, that's 180 plus 76 is 256 degrees, right? So that's the angle between 0 and 360. But what if I change the domain for it on you? What if I wanted the angle to be between 500 and 700 degrees? What would I do to find an angle that has those tan, sine, and cosine ratios, but that is between 500 and 700 degrees? Alyssa? Yeah, we would either add or subtract 360 for us. So we would add 360 to this. 256 plus 360 gives me 616 degrees, and that is in the domain. And if I added another 360, I'd be outside of the domain. So that would be the answer. So that angle there is coterminal with this angle. So they have all the same trig ratios, but this is the one that meets that domain restriction. Okay? Make sense? So watch out, because they're going to change the domains on you on these questions. Demetria?
So when you're finding the reference angle, the sine to the -1 is sine, and then just sine would be cos.
Correct. Okay. Sine to the -1 is the inverse of sine. It is not the reciprocal of sine. So be careful of that. We're using the -1 here, which I didn't put here, and I meant to. We're using the -1 here to indicate the inverse of sine, cosine, and tangent, not the reciprocal of sine, cosine, and tangent. Correct. Okay. One last example. This is another kind of question that you can see. So I'm telling you what the trig ratio is, secant 4, and I'm asking you to find all the other trig ratios and find the exact values for them. Okay? Now, if I tell you that secant theta equals 4, there's one you know right away without doing too much work at all. If you know secant, what else do you also know? Cosine, right? Cosine theta must be the reciprocal of that. So we know secant and we know cosine, but your job is to find sine and tangent and cotangent and cosecant. Okay? So we'll make this quick. Secant is positive and cosine is positive here. And in which quadrant are we going to find positive cosine and secant? Fourth quadrant and also first quadrant, okay? So that's why I have two parts to this question. Between 0 and 180, that's just quadrant 1. So I'm looking for only a triangle here in the first quadrant. But here, if I have between 0 and 360, all 4 quadrants, then cosine is only positive in the first quadrant and the fourth quadrant. Okay? Now, cosine, if you recall, is adjacent over hypotenuse. So the adjacent side is here and the hypotenuse is there. So if I use the Pythagorean theorem, I can find this side here to be root 15. And now you can find the sine, the cosine, the tangent, the cotangent, and so on, just by using the correct ratios. Down here, if I'm in quadrant 4, now the sine, the tangent, the cotangent, the cosecant all become negative. So we'll have positive and negative for those 4, but cosine and secant will be positive in both of those quadrants. Okay? So I'm going to leave it there. I know you were wanting to have your test marks, so I will bring you